So cognitive radio. Uh, so here cognitive means intelligent. So this one is kind of intelligent radio. Currently, we have now AI. We have machine learning. So if you see cognitive radio uh, in that scenario, so it fits in because we have now the capabilities of AI and machine learning. Through that, we can have these cognitive radios. So this idea was being shared like a decade and 2 decades ago. That around 2006, I think. Before that, a scientist like J. Mitola, he first gave this concept. So this technology was there to play an important role in the future generations of radio communication systems. So the idea is to utilize unutilized spectrum that is being wasted or being unused at a given time in a way that it should not be interfering with the primary users. Like primary user here is the one who is subscribed to use their service. Like we purchase a SIM card of a particular cellular operator. That means we are the primary users because we are paying that. But uh, not necessary that at any given time, all the resources, those are allocated to a base station or an RNC or eNode B are fully utilized by the users. Maybe 100% utilization, sometime it reaches 100% utilization, but most of the time, there will be some spectrum that may not be used properly or are wasted. So cognitive radio is something that uh, promises to use that unused or wasted spectrum in a way that it will not interfere with the primary users. So that is the idea behind that. So it's a system that understands the context in which it finds itself and as a result can tailor the communication process in line with that understanding. A radio communication system with a brain. So there are currently numerous communication systems making use of smart radios which can adapt their behavior in many ways. Example, CR takes this type of adaptive behavior much further by greatly increasing the level of adaptivity, which applies to a wider range of parameters. That is operating frequency, bandwidth, transmit power, modulation scheme, battery usage, processor usage, etc. Now, cognitive radios users are termed as the secondary users in the literature, and the one who are licensed users are the subscribed users are termed as the primary users. So it can be said as the cognitive radio usage is the opportunistic use. Wherever it sees an opportunity, that means an spectrum is there that is being unused or being unutilized at a given time, it can opportunistically use that spectrum. So that utilization can be in any type of network. So it need to adopt its operating frequency and other parameters like mentioned here, listed from operating frequency to processor, battery usage, modulation scheme. As different networks have different operating parameters. So first phase is learning. Cognitive radio recognizes patterns of behavior, learns from reoccurring situations, and uses mechanisms to anticipate future events. Has the ability to learn from its action and feed this learning to influence any future reactions. Ditto to the machine learning. Machine learning also takes the data as an input, that is data. We train the system, we train the machine. Based on that training, machine learns and will act on their learning in future and will improve its performance based on their learning and the occurrence of the events. Similar to that, cognitive radio also does that. It also recognizes patterns of behavior, learns from reoccurring situations, and has the ability to learn from its action and feed this to influence its any future reactions. So it's made of a software and hardware components to facilitate a wide variety of different configurations for its communication, reconfigurable hardware. So it's a revolutionary evolution of software-defined radio. So basically, it's cognitive radio is a software-defined radio. The main application that can be seen at this point can be the emergency services in case of any uh, natural disaster, maybe floods, maybe something else, where the infrastructure uh, hit by the that natural disaster. In that case, whatever the available resources we have in that for communication purpose, cognitive radio can utilize those available resources which may be working at that time. So in conventional radio that supports a fixed number of systems, reconfigurable, decided at the time of design. Many support multiple services but chosen at the time of design. Traditional RF design plus traditional baseband design, typically radios are not upgradable. Like if we have seen around us, we have two popular services around us. One is FM radio, one is cellular communication, that is again cellular radio. So both have different frequencies, different parameters, different modulation scheme, but both has the transmitter, both has the frequency, but their hardware that is designed in a way that only fits in those particular applications. Means a transmitter designed for FM can only work in FM. It will not work in cellular. Similarly, a cellular transceiver cannot work in the FM transmitter. But the cognitive radio, it's software-defined radio. It can adapt both these systems, configuration of both these systems. So that is how cognitive radio is different from the conventional radio. So the advantage of being a software radio is dynamically support multiple variable system as the two systems. I gave you an example, FM and cellular, their protocols and interfaces as well. Interfaces with diverse systems provide a wide range of services with variable quality of service. Conventional radio plus software architecture plus reconfigurability. Those are the strong advantages of this CR. Cognitive radio provenance of EV upgrades also there. It also create new waveforms on its own, can negotiate new interfaces, adjust operations to meet the quality of service required by the application for the signal environment. Signal software defined radio plus intelligent plus awareness plus learning plus observations. So you can say that we had put the machine learning in the conventional radio that makes it cognitive radio, and as a one software defined technology was also there. So software defined technology with the radio becomes software defined radio. And other things comes from the machine learning. Machines are intelligent, they learn, aware, and then become intelligent based on their observations. So SDR upgrade mechanisms plus internal upgrades plus collaborative upgrades. So if you want the update, it can be upgraded. Like in machine learning, we change the database. Machine remain the same. The only thing that we change the databases are becoming new versions of databases also being updated or being published every year. So where it can be used, spectrum trading, cheaper radios, automated interoperability, improving reliability, collaborative techniques, intelligent beamforming, advanced networking, opportunistic spectrum utilization. So it has uh, plenty of applications to offer, but at this time, none of these has been taken seriously, especially in our country. It is not recognized in few countries other than in few developed countries. It has been recognized and being used for opportunistic spectrum utilization. So, what was the idea, the motivation behind this cognitive radio? The first thing that we need to transmit data from one point to another, we need a spectrum, and frequency spectrum is a thing that is not only scarce but is also very expensive. But it is well dominated that frequency regulators have allocated the frequency spectrum in an inefficient and an unoptimized manner. So the available spectrum that we had already being allocated without taking into consideration what will be the future applications have been given more bandwidth than their capacity, then their requirement, but that is already being assigned and that is fixed general assignment. So out of that, 50% to 70% of useful spectrum remains unutilized. So the idea is to utilize that unutilized spectrum through cognitive radio. So in this figure, you can see spares use, medium use, and there are some unused spectrum. You can see the idea is to utilize those frequencies that are unused by the primary users. So we call them white spaces, unutilized frequency. We call that a white space. So cognitive radio can sense where the white spaces are available, then dynamically adapt its physical layer and higher layers to use that spectrum. Because these white spaces can be available in any site in any type of network. So to access that spectrum, you need to must have same protocols and same configuration. So cognitive radio should be able to adjust to the environment of that particular network or the tech uh, system from where it is being taking that wide spaces. So all the processing takes place on the FPGA or DSP enabled hardware. Reason why DSP is so important for telecommunication engineering. So these are functions. First is spectrum sensing, that is detecting unused spectrum and sharing the spectrum without harmful interference with other users. Then spectrum management, that is capturing the best available spectrum to meet user communication requirements. Spectrum mobility, maintaining a seamless communication requirements during the transition to the better spectrum. Spectrum sharing, providing fair spectrum scheduling method among coexisting CR users. It's a black box and an intelligent SDR that can tune in its parameters in a flexible manner. Network experience example, bit error rate, SNR, what you see, environmental conditions, what you can tune, what you can be allowable, device configurations. So a physical layer perspective, one is programmable, one is tunable. So it's not something like fixed. It can only be used in one application. It can adjust to any particular configuration. Spectrum sensing, in order to avoid interference, the spectrum holes need to be sensed. First, you need to make sure that there are spectrum holes available so that you can only know by sensing the spectrum. Primary user detection, the most efficient way. Primary users are the one like I have a U-phone SIM. Okay, so that means I am kind of a registered user of U-phone means I am a primary user. But it's not necessary that I am using my mobile cellular phone all the time. That means 24 hours It's not practical for me that I am communicating over my phone for 24 hours. That means not possible. So there is time, not for our users, it's not possible to have communication over 24 hours. So there will be some resources which are free at any given time. So to utilize those free resources, we have this cognitive radio, but it should be in a way that whenever primary user wants to access those resources which are being used by the cognitive radio, then we say the secondary users or the secondary utilization by the secondary users. Primary users should not be getting any interference from the secondary user or any hindrance in accessing their spectrum, because primarily it is their spectrum that we are sneaking in and utilizing it when it is unutilized. So spectrum sensing is based on three interference-based detection, transmitter detection, and cooperative detection. Transmitter detection again has three: mesh filter, cyclostationary detection, and energy detection. Enable dynamic spectrum access for secondary user to the wide spaces. Various approaches. One is a spectrum underlay and one is a spectrum overlay. So that is the two approaches: spectrum underlay and spectrum overlay. Spectrum underlay, same frequency but with less power, and spectrum overlay, available frequency with the same power as that of the primary users. This is a typical figure of secondary and primary users. Available frequency is being used by the secondary users when there is unutilized frequency. So that is cognitive radio. If you have any questions from it, you can ask.
नो सर, बस इते खत्म थियो वायरलेस जो।
YMX आहे चओ थो पढ़ूं या छॾियूं, जीअं चओ था।
सर सर छॾियो सर, तव्हांजी तबियत बि सही न आहे ऐं बसि एतिरो खोड़ आहे कोर्स।
कोर्स थोर थी वियो आहे।
हा सर, असल में बाक़ी था पेपर न त एतिरो कवर करण थी थी वेंदो सर।
चलो ठीकु आहे, मां वो ठाहे रखां थो तव्हां लाइ आहे